Welcome, welcome to our new unit, Chemical Equations, by your teacher, Ms. Sacconi. What is a chemical equation? A chemical equation is the shorthand way that a scientist describes a chemical reaction. Remember that a chemical reaction is also the same as a chemical change, just a different way of saying it. Equations show chemistry in action. Equations show us exactly what is taking place. The first thing that we see are the reactants which enter into the reaction, the products which are formed by the reaction, and the state of matter of each reactant and product. The anatomy of a chemical equation. When we write a chemical equation, we use the symbols for elements and compounds. We learned how to do this in our last unit, so I hope that you remember. The left-hand side of a chemical equation are what we call the reactants. These are the items that are reacting. The elements or compounds on the right-hand side are what is being produced by the reaction, and we call those products. In between the reactants and the products, you will see an arrow. An arrow shows us the direction of the reaction, and we read it as yields or produces. Later on in the semester, we will encounter reversible reactions, and that is denoted by the double-headed arrow. When you look at each of the reactants and products, you will note a new subscript. On this one, we have a lowercase g and a lowercase l. They very simply stand for the state of matter of each reactant and product. S being solid, L being liquid, G being gas. AQ is one that we're going to frequently run across, and that stands for aqueous. That is a substance dissolved in water. If you recall from our lab last week, we used at least 10 different aqueous solutions. Now here's where the fun begins. We're going to learn how to write an equation from a word problem. This is where our entire last unit comes into play. For this one, we have fluorine gas and oxygen gas react to produce oxygen difluoride gas. I hope that you can tell from reading this equation that we are dealing with a molecular or covalent compound because of the use of the prefix di, and by the fact that both fluorine and oxygen are nonmetals. Number 1, we read the sentence and we identify the elements or compounds that are reacting. Then we identify the elements or compounds that are being produced by that reaction. Note the states of matter. Never ever forget the diatomic molecules. And then write the equation. The diatomic molecules are the ones we figured in class that began with element number 7, take on the shape of a 7, and include the element hydrogen. Diatomic means 2 atoms together. So when we write this equation, we know that fluorine is a diatomic molecule, and we know that oxygen is a diatomic molecule. So the proper way to write it is, first we have fluorine gas, We make it diatomic, and we have the G as a subscript. Then we write fluorine again with the G as a subscript, and oxygen, which is also a diatomic molecule, as well as a gas. The plus sign in between the two indicates that we are joining those two together to form a new product. The new product here that we formed is called oxygen difluoride. I wrote oxygen difluoride by reading the name oxygen. Note that there is no prefix with that, which indicates there is only one. And we have difluoride, and the prefix di indicates that we have two. Next, we're going to learn how to write a word problem from an equation. What we're going to do here is we're going to look at each reactant, note their state of matter, and the product, again noting the state of matter. I know that magnesium and oxygen together form an ionic compound. I know that water is simply just written as water when it's in its liquid form. And this is not a binary ionic, but a polyatomic ionic compound. The way we write this is we do it in a complete sentence. We say solid magnesium oxide. Remember how to name ionic compounds. This is where it's most important. Reacts with water to produce solid magnesium hydroxide. Notice that with my ionic compounds, I did not use a Roman numeral. I only need to use a Roman numeral if the metals involved in the reaction are transition metals. I want you to pause on each slide and make sure you take really good notes.